All right, welcome back. So today we are going to be talking about what are called special case equations. And they have a different name to them because, well, they are special cases. And we are going to be going through different examples and how we can visualize and tell whether an equation is our quote unquote normal equation or a special case equation. So without further ado, let's begin. So normally we are used to seeing equations that look like this. So for example, we have 2x plus 5 is equal to 3x plus 4. We want to solve this equation to get the solution of the equation, so we want to isolate our variable, in this case is x. So we need to first simplify each side of the equal sign. So let's just take a gander at 2x plus 5. Can we simplify 2x plus 5? Are those like terms? Is there any operation we can do? I don't really think so. 2x plus 5 are not like terms, so that's fully simplified. Let's look at 3x plus 4. Is 3x plus 4 simplified? Yes, it is. Those are not like terms. So first off, we are good to go. Both sides of our equal sign are fully simplified, which is a great sign. So now we need to get our variables over to one side and our constants, those are the terms without a variable, over to the other side. Now normally whenever I move my variables, I always move my variables first, and that's a huge tip for you. Always move your variables first, especially today because something special is going to occur. So when I want to move my variables, I look for the greater coefficient. Right now we have a coefficient of 2 and we have a coefficient of 3. Well, comparing 2 and 3, I see that 3 is bigger. So what I like to do is I like to move my variables to the side of the bigger coefficient. So I want to bring this 2x over to 3x. To do so, I subtract 2x on both sides. This goes to 0, which is perfect. So now we're left with 5 is equal to 3x minus 2x, which is 1x plus 4. Notice how my variable, the coefficient, is positive. When you move the lesser coefficient to the side of the bigger coefficient, or the greater coefficient, I should say, it's going to be positive. And now we have our variable on the right-hand side, which means we need to get our constant on the left-hand side. I need to remove this plus 4, so I'm going to subtract 4. What I do to one side, I do to the other. This goes to 0, so now we're left with 5 minus 4, which is 1. And we drop down everything else, which is our answer. So 1 is equal to x. I know a lot of students also put x is equal to 1. That's 6 to 1, half a dozen the other. So these are the problems we're normally used to seeing, but today we're going to be going over special cases. So let's talk about one. Let's solve this equation. So we have 2x plus 1 on the left-hand side, 2x minus 1 on the right-hand side. Okay? Let's look at each expression. So 2x plus 1, can I simplify 2x plus 1 at all? Nah, it's fully simplified. Can I simplify 2x minus 1 at all? No, again, that's fully simplified, which means we're now going to want to bring over our variables to one side and our constants to the other side. Well, I look at my variables and I see their coefficient. I have 2 and of 2, which makes me question what number is bigger. Well, they're the same. So in this case, it doesn't matter which side we bring our variables over to. But I am going to bring them over, let's say, to the right-hand side over here. So to do that, I subtract 2x on both sides. So what I do to one side, I do to the other. This goes to 0. So 2x minus 2x, that is 0x. But we don't really write 0x, we just don't write anything. So this also cancels out. Uh-oh. So all we're left with is technically plus 1 is equal to minus 1. But again, we don't write that plus 1. So we have 1 is equal to negative 1. Is this true? No. Having $1 is not the same as owing $1. So this is a false statement. And notice how we're only left with constants here. Our variables canceled out. We had the same term on both sides of the equal sign. So when we perform that inverse operation, in this case it was subtracting 2x from both sides, they both actually went to 0. So we're just left with 1 is equal to -1. But we know that's false. So this is our first case of a special case equation. We call this a no solution. We call this a no solution. And the reason why we call this a no solution is because we canceled out our variables. We don't have a variable anymore to even solve for. We only have our constants of 1 is equal to -1. So since, again, no more variables, they canceled out, our constants are not equal to each other, that's a false statement, our final answer is no solution. That means no matter what value of x or whatever value of our variable we try to substitute into these equations, it's never going to yield a true statement, right? So for example, if I wanted to just do a quick one, I have 2x plus 1 is equal to 2x minus 1. Let's say x is equal to 5. Let x equal to 5. Well, when I plug that value in, I get 2 times 5 plus 1, and that should be equal to 2 times 5 minus 1. Well, when we simplify, 2 times 5 is 10 plus 1 is 11, and 2 times 5 is 10 minus 1 is 9. So 11 is not equal to 9. 1 is not equal to -1. So no matter what value we substitute in for our variable, this will never yield a true statement. It's always going to be a false statement. That's why we call it a no solution. Well, let's look on the other side of this special case. Let's say we have this equation here. Pause it, jot it down, and then resume when you are ready to move on. So within this equation here, the first thing we want to do, as always, is try to identify if we can simplify either side of the equal sign. Well, I have 6 times 5 minus 2x. I can definitely simplify this side of the equal sign. So let's do it. I'm going to distribute that 6 to my 5 and to that minus 2x, so we call it the negative 2x. So when we do so, we get 30 minus 12x. And let's look now on the right-hand side of our equal sign. Let's look right here. -4 times 3x plus 1. Can I simplify that? Yeah, most definitely. So let's actually do that. Let's simplify that side of the equal sign. Well, I'm going to distribute that -4. -4 times 3x is -12x. -4 plus times 1, is -4. Now, can we simplify either side of the equal sign? No, we can't. So we want to bring over our variables. Well, I'm comparing. I have -12x and -12x. Those are the same numbers. So just like before, it doesn't matter which side we bring them to, because something special might happen. But let's say I want to bring them over to the right-hand side. If I add 12x, this now goes to 0, which is good. But now when I add 12x over here, well, this also goes to 0x. But again, we don't write 0x. We are just going to leave it as 0 or not even write anything. So this also goes to 0. So now we're left with 6 times 5 we had was 30. That's equal to now -4. Again, is this a no solution? Yes, it is. Yes, it is. This is a no solution again. This is going to be a no solution because 30 is not equal to -4. Awesome. Awesome. Let's do one more. Let's say we have 3x plus 3 is equal to 3x plus 3. A lot of 3's. I know. It's all right. So again, we want to look and see, can we simplify anything on either side of the equal sign? And no, we cannot. So we want to bring our variables over. I think I'm going to bring my variables to the left-hand side here. So when I subtract 3x, this goes to 0, which is good. But again, we're noticing that, well, this also goes to 0. We drop down everything else, and we're left with 3 is equal to 3. Is that true? Is 3 equal to 3? Yes, this is a true statement. So since it is a true statement, we say it has many solutions. Our final answer here would be many solutions. Now, you might have some people say it's infinitely many solutions. You might hear all real numbers. For our case, we can just say there's many solutions. And this means that whatever value of x we want to substitute into the equation, it's going to yield a true statement. So let's say we actually did that. Let's say that we tried it out, right? So let's do that. 3x plus 3 is equal to 3x plus 3. Let's let x be 1. Right? Let's just say x is 1. Well, when we substitute it in, we get 3 times 1 plus 3 is equal again to 3 times 1 plus 3. 3 times 1 is 3, plus 3 is 6. So we get 6 is equal to 6. Well, let's try it again. Let's say 3x plus 3 is equal to 3x plus 3. This time, let's let x be equal to 2. Well, when we go and plug our value in, we get 3 times 2. That should have been in green. Let's try it again. Plus 3 is equal to 3 times 2 plus 3. We simplify it down, we get 9 is equal to 9, again, which is true. And that should make sense because the left-hand side of the equal sign is the exact same as the right-hand side of the equal sign. So that's why we get many solutions, because whatever value of x we substitute in, it's going to be a true statement because both of the sides of our equal sign are identical. They are the exact same. So here's a quick visual to help you out with that. When we have a one solution setup, we're going to get an answer. So for example, we're going to have x is equal to 4. And it's going to have our variables, the coefficients are going to be different. Notice here that we have a coefficient of 3 and a coefficient of 2. This is what we call a normal solution or a one solution case. When we move into no solutions, notice how, again, our variables, they have the same coefficient, so they both have 4, but the difference is that our constants are different. So we have a 12 and we have a 6. So we end up with 12 is equal to 6, and we know that is not true. It's no bueno, right? So 12 is not equal to 6. That's why we have a no solution. And lastly, within our many solutions, we're going to end up with a true statement because both the left and the right-hand side of our equal signs are identical.